All right, so let's have a look at the Modbus application protocol or MBAP header, which consists of the transaction identifier, the protocol identifier, the length, and the unit ID. So I'm going to start with the protocol identifier. It says this field is always 0 for Modbus services and other values are reserved for future extensions. So it's just a sort of a reserved part of the MBAP header for extensions of Modbus. But right now, all you need to be concerned with and all you need to know is that it's always 0, all right? For any combination or permutation of this frame here, all right? Length. So this field, this length field, is the byte count of the remaining fields, which includes the unit ID, the function code, and however many 8-bit data bytes are there. So that's this, the figure that'll be in here is the number of bytes in these three right here. Okay, pretty simple. And then we have the unit ID. Now, I know it's a little confusing. I took out the address from the data frame, where they had address, function code, 8-bit data byte, and error check. And yet we have this unit ID here. We don't need a unit ID for normal Modbus TCP IP communications, because we have the IP address. However, in certain cases, it says this field is used for serial bridging to identify a remote server on a non-TCP IP network, a non-TCP IP network. Sometimes there will be devices, but very rarely, that will actually be connected via a bridge, and that bridge might be, let's say, a TCP IP to RS-232 or TCP IP to RS-485 bridge. And let's say a client is trying to communicate a server on that bridge, it'll use this unit ID here. But for now, for what we will be doing, it will really not be used. Okay, good. So in the next lecture, I'm going to look at the transaction identifier, because that is probably the most important part of the Modbus application protocol header, and it's probably the most difficult to understand. So I'm going to spend an entire lecture on that. Okay.